Hey guys, it's hey guys, it's Stephen from Legit Tutorials and the Green Engineers. I'm sitting here with my cat Tiger. Oh, so yeah, if you ever hear me say that name, my cat's name is Tiger. So, anyways, yeah, so let's go ahead and continue on with the Shredder development series. So we just have a couple more videos left, and this is going to be a pretty exciting series where I'm going to show you guys kind of the end product when it is fully completed. Whether or not I will follow all of the changes, I probably won't, because there's going to be a lot of iterative designs like, oh hey, this material is, I find more than this other material, and so we're going to go with this material and other stuff like that. So I'm thinking a couple more videos. We have to do the motor. We have to basically we have to just do the motor, and we done the hopper. We have a couple issues on the hopper. Whether or not I fix that in the series, I don't know. So let's see what we got here. But I think for right now that one of those on Amazon, and we could look at some of these calculations here also. Then maybe go on AliExpress. So this is a good one here, the Porter cable, and obviously we don't want air. Wow, this is 300 with a 20 volt. That's pretty good. This is 450. This is a lot of torque. Okay, so let's say we have the 450 and we want to drop it from 2200 RPM down to 80. Oops. So it looks like 27.5. Okay. 27.5 times. So again, I think this one was, if we look back at our assembly here, and this was 80. I'm thinking 2200. I'm thinking 61 per second, I think is plenty fine. So in this case, it's going to cut twice per rotation. Oops. Yes, 3 inches. Whoops, 3 inches divided by 36.7, or 67, let's say. It's very small, 80 thousandths. Now that might be the same size as that foretooth, right? But that foretooth is probably not at 2000 RPM. So one of the things that I want to check is this thing actually 2000 RPM? Or is the motor inside 2000 RPM? I doubt it is 2000 RPM. Because if we do 2000 RPM, talking 33 rotations a second. I don't think so. Let's see. So if we click on this, this is a second. So every time this clicks, it's rotated 33 times. I don't think so. I think that is a very idealistic case. And then obviously that 80 is max speed. So let's say it has so another thing that we have to look at here. So let's say that is max speed, let's say, right? And let's say that we have, oops, this is supposed to be 2200. Oh, sorry. Yeah, this is the max speed, so it's actually higher than that. 2200 divided by 60 seconds in a minute, so that's 37, almost 37 rotations per minute. So, another thing is that if that's 2200, then generally the maximum efficiency of a motor is that times 0.8, right? That's 1760, so let's say 60, or 1760 divided by 60, that's 30 times. So 3 divided by 30 is 0.1. 0.1's pretty small. I don't think even that foretooth is that small. Another thing that we could maybe do is even run a some sort of larger apparatus, some sort of brushless motor. So let's see what we have for large. 500 kV. Let's say we run it on 24. But see, here's the issue: no load current, no load speed, 5600, 9800, 9600. Max current 80. Max watts. So let's say we find a 36 volt power supply. 560 divided by 36. That's 15 amp. And then obviously the lower the amperage, the less heat that you have, and the less extra heat that you're generating. So I'm thinking that this is going to be something that is probably going to be our best bet. And the cool thing is that from the time being, it's going to function as a controller too here with the directions, which I think is pretty cool. I don't think that it's going to have this 2200 RPM. I doubt it. Let me see. Let's see if we could, let's look this thing up. Mute. Is that a Mustang? Maybe not. Maybe that's a AC Cobra or something. Looks kind of like a Cobra. Let's hear it a little bit.
Just went to Harbor Freight, and I got this 3/4 inch. I can't work with one hand. There we go. So this thing has reverse and forward. So let's see what happens.
So let's see after it removes the lug nut. Okay, maybe this does have that speed. So 37 times, rotate 37 times a second. I still don't think, even then, I wish we could look at it frame by frame and have a little thing here.
Oh, wow. That's a piece of cake. So let's try. Yes, this is ready now for torquing. Wow. Excellent investment.
So maybe these are that kind of speed. Well, I mean, I think that I should maybe buy one from Harbor Freight, tear it apart. Spend one for $80. I mean, obviously it's way better machine, but and way a higher torque than these other ones, but than this, standard run-the-mill one from these guys. And obviously more power. Well, this is 7 amps. The other one's 7.5. This is 230. And this one's slightly lower RPM. And then obviously this one's got like double, about 450. This has got 230 foot-pounds torque. But we are going to step it down. But the step down, I think, is not going to be the best, as much as we can, because of a couple of losses there. So I'm thinking it already has a gear train in there, and then maybe we'll add one gear here, so we could have that small gear, and then we could have another gear, and see what happens. But I just want to get this thing and tear it apart. I think it would be worth the $50 to get it and tear it apart. Again, like I said, if this was the actual product, I would probably have something like that ported cable. And also, let's look at that. Oops. Let's look at that the calculations involved here. So I need to remind myself. So basically the idea so basically a small gear like that, and it goes into this little 4-tooth whatever. Okay, so this is actually what I wrote. And here I am, the Green Engineers. And there's my logo up there. So basically what I'm looking at here is what's called shear, which is pretty much when you have two pieces of material that come together with the teeth, and basically what it does is it breaks the bonds between those two teeth and it just separates the material. So it's like using scissors. It just cuts the material by basically causing the bonds to not be strong enough to hold the material together, so they just separate and it becomes from one piece of material to two pieces of material. Now basically what you do is you create a shear, like a crack in the grain of the material, and it propagates, and you create so many cracks that that basically all the bonds are broken. Now this thing separates, right? So pretty much what you need is you need to know what material you're cutting and then the cross-sectional area, which is if you were to cut your material in half, or basically what area is between the two blades. So how much area of bonds do you have to break of the material? And so usually you do a worst case scenario. So I did like a triangle. And so this is the biggest triangle that will fit inside my machine to cut. And we're saying here high density polyethylene, and then this is obviously solid. This is not like a milk jug. So it says yield strength is 4350 of that guy. So I'm going to say 80% of that as rule of thumb, because generally the shear stress is about 80% of the yield. Okay. Force is 3,500 times 0.5. I think that's the... This is 0.5 area, inches squared. 1750, that equals 1750 pounds of force. How much torque I need from the motor? 4 times distance, so torque. So basically, and then this torque is pretty much, you count from the center of the shaft up to the tip of the blade. So this is basically to the tip of the blade. So it says here we have 3063 inch-pounds of torque. So 3063 inch-pounds. So here it says 2.32 at I don't know what, I guess this is 550. So now equation to find horsepower is RPM, rotation per minute, times torque, all divided by 5252. So RPM inch pounds to foot pounds. So it's just divided by 12. Yeah. Foot pounds, yeah, so inch pounds to foot pounds, it's linear, so you just divide the inch pounds by 12. So we're talking 255 foot pounds. So that is actually, so 255, we're already really, really close. And this is without dropping the RPM at all. So realistically speaking, this guy should be able to do, and here's the conversion. You just take the 3063 and you divide it by the 255. By the 3063 divided by 12, that's 255. And you see here that we have 230. So this would work perfectly. So obviously we're going to even almost be able to do it without even dropping the RPM. But basically what that means here is that this is the max torque, so this is probably at the bottom where it's doing its hammer thing, right? Which maybe even the hammer thing might even help. I'll have to look. I'll do some studying on it. It might just try to, just destroy the whole machine. But it might help with, basically creating impulse. Because that's the idea, is that it comes in and creates an impulse, and maybe that impulse is enough to, create a big fracture in the material and then cause it to, go freely. What about this little guy? Yeah, very low. So yeah, I mean, if I was going to tear something apart, I'd rather it be the Harbor Freight, and then maybe I might even be able to return it or something, put it back together all correctly, and then be able to return it. And it's something that I wouldn't be too disappointed with if I modded it and do all that kind of jazz. So that's what I think I'm going to do. I'm going to go to Harbor Freight, and we'll look at it maybe tomorrow. We'll see. I might stop by there on the way home from work, and we will tear it apart and see what it looks like on the inside. Because actually I'm going to come down totally tomorrow, so I should be able to stop by Harbor Freight and take a look at it and buy that, and then we'll take it apart. So clearly it's going to work for our application, so that's good. So that's what I'm thinking that I'm going to do, and then from there we'll be able to pick how we're going to mount it. And so let's talk a little bit about how I'm thinking of mounting it. So obviously the gear train here, figure out what the gear train is on the inside and how I'm going to get it onto this piece here. So once I have that, number one thing is going to have probably this piece and this piece here. So when I put the hopper, that might cause some weirdness. So what I'm thinking is I might need to have it where it uses that plate anyways. Remember how I deleted the plate on the hopper? Because I need something that I could use to mount this on, or it could go on top of the hopper. What I'm thinking is probably, I don't think it's really needed, so we could have it where it goes on top, it bolts on top of the hopper itself, or even, it uses already these, existent holes here and goes underneath. But then again, it's going to obviously obstruct with the stand as well. So we're going to pick one side, and then maybe what I should do is add some bolt holes later on. I could do that before I ship these out. I could drill into these things and put bolt holes in them to begin with. So extra 2 bolt holes for the motor, and the motor will just run there. But pretty much what we're going to look at is the stand. So maybe we might move how this thing is kind of put together like that. But pretty much that motor is going to go right smack dab in between these two pieces here. So have the same kind of plate here, same kind of plate here, and then have the motor come forward. The centerpiece of the motor sticks out here, and then probably do a 2-piece gear train that goes out to this main one here, and then obviously it needs to spin this guy inward, or this guy clockwise, and then this guy will spin counterclockwise, and then now you have the crunching of the stuff in here. So that's kind of the thought. It really depends when I take this thing apart what it looks like on the inside. I mean, obviously, as we see here, very little plastic's going to stand a chance unless it's a composite, but you can't really recycle a composite anyways, so I don't know why you're doing that. But you can see that we're already pretty much have the maximum torque without even gearing it, which is pretty nice. So I'm thinking that you could probably even do it without gearing it, but it's difficult. I mean, you could do that. So basically what would happen is that it's got this holder that cantilevers it out, and then the motor comes forward and just mates right up with this thing. Which you could do that, but again, I believe that the torque should be slightly higher. So even if I did the 300, even if I did this one, I could probably have it mate right up to this guy and still not have any issues. Unless I do, maximum thickness stuff. But again, if I'm doing, plastic water bottles, doing a whole bunch of them, and then decide to step up to something thicker, I think it will get most of the stuff done. And then instead of being out $80, taking it apart, then I blow something up or whatever, I'm out $50, which is, $30 savings. I can almost get 2 of those ones. So I'm thinking that that's what needs to happen, but I do need one of those units on hand so that I can take it apart and we look at the bolt pattern on the inside and go from there. So I'll go to Harbor Freight tomorrow. I'm also going to the paint store tomorrow, and we will get these pieces, and we will see. I'll get this impact wrench, and we will take it. We'll take it apart, and yeah. So that's what I'm thinking. We will move forward with this, and I'll go in with $50, and I think that's a really good deal for a motor. I might have to go on to the this website and mention that I use an impact wrench because they're pretty big on the torque. So that's good. All right, so. That's basically what we're going to need to move forward, is to have one of these guys available, and I get my calipers on it, and we could look at the overall length and how it would fit, which I think would fit very well. And then, like I said, the cool thing is that pretty much how you could have this orientated is pretty much have clamps on this thing and have it to where you just use the trigger to go back and forth, and then this guy just goes out, and you could literally jerry rig a one of these guys, and then I could have some sort of one of these guys made so that laser cut, so that it goes on there and it slides onto the head of this impact wrench, and it just goes over here and mates up with these other guys. Probably going to have to do some sort of flat assembly with some sort of bearing pressed in, because it's probably going to need to have an intermediary just to drop the RPM and go from this one to this one, and then I'll be able to get the torque out of it that I need. And again, like I said, even if I do from the get-go, I have it directly bolted in here, and then goes over here and directly interfaces in here, I think it should be fine. But for the production, I'd probably drop the RPM just for a little bit more torque, maybe even cut it in half. And even if we doubled the maximum torque to 450, we're way over what I see for the maximum material. And again, this is not saying, obviously, if you had something like PLA, that's way harder. And if it was solid, not 3D printed, and you injection molded a triangle out of that 230 foot-pounds would not do it. So also, I ordered the bearings, and I have notification that my samples have been shipped. So everything's coming together here, and soon I'll be buying equipment here at the house so that I could have a grinder and drill press and finger bender, that kind of stuff. And then I'm still working on my water jet, so that's also coming together. All right, guys, thank you so much for watching. More, probably better video coming tomorrow when we have this torque wrench in hand, and we were able to take some measurements on how to mount it up to this guy, and then the possibility of doing direct drive or gearing it. Thank you guys so much for watching, and I'll see you guys tomorrow. And then after that, it's the weekend, and we'll take a little break. And next week, I actually have work. I actually have the week off of work, so we're gonna have probably some more. I might start up another series temporarily for that week, just to get everything going. Or I might go even more full speed on the shredder to get everything finalized and build a working prototype for all of these pieces, as far as the stand and the hopper. All right, thank you guys so much for watching, and I'll see you guys next video. Take it easy. Peace.